there are two models developed for representing synchronous sequential circuits, and we will talk about these two models in depth. In this presentation, I will dictate one model, and in the next presentation, we will talk about the another one. So what are these two models? Let me write the names of these two models. The first one is the Moore circuit, M-O-O-R-E circuit, and it is also called as Moore state machines. And the second one is the Mealy, M-E-A-L-Y circuit, or it is called as the Mealy state machine. Okay, these are the two models that we have to see, and they are very important if I talk about the state diagrams. So what are these two models and how they are different from each other? The main question is how they are different from each other. So they differ only in the way the output is generated. You already know what is sequential circuit. It consists of the combinational circuit and a memory block. The memory block is nothing but your flip-flops, and if you want to calculate the output, okay, then it may depend upon the input and definitely the present state, but sometimes it doesn't depend upon the input, and in that case we call it the Moore circuit. So let me write this important point down. The difference between these two circuits is only in the way the output is generated. So we have to see how the output is being generated in the Moore circuit and how the output is being generated in the Mealy circuit. So we will first see the output of the Moore circuit, and in this case the output is the function of the present state only. The output is the function. I want you to write these points down so that it may help you later. The output is the function of present state only. Okay, here only is there, so it only depends upon the present state, whereas in case of Mealy state machines, the output is the function of present state as well as the input. Okay, so this is the main difference between the Mealy and the Moore state machines, and in this presentation we will talk about the Moore state machine, and in the next presentation we will see what is the Mealy machine. So here you can see a block diagram is there of the sequential circuit, of course, and this combinational logic is there, which we call as the next state combinational logic, sometimes also called as the next state decoder. The next state of the sequential circuit will be decided upon the logic given here, and whatever be the next state is stored here, and the one important thing that you can see here is the another combinational logic, and depending upon which the output is being generated. And here you can clearly see that the output is only the function of this present state. This is my present state. The present state is stored in this memory, and the output you can see is only determined by the value of this present state. There is no impact of this input directly on the output. The input is not given in this combinational logic, so the output is function of only the present state, and that's what we have written here. The output is the function of only present state. So this shows the Moore model of the sequential circuit. Now I will show you one example in which we will try to find out whether it is a Moore circuit or it is a Mealy circuit. So I will paste it down. This is the example in which I have used the T flip-flops and some gates. So let's try to find out what is the next state combinational logic in this circuit, in this sequential circuit, and what is the output combinational logic. So let's try to find that thing first. You can see here the input is A is given to this two logic gates, and this is our next state logic, combinational logic, and this OR gate is our output combinational logic. So we have found out these things, and now we will try to find out the value of y. on what factor y is been depending. So here you can see there are two inputs to this OR gate. A two input OR gate is being used, and the output, that is our y, this is our output, is the output of this OR gate. So whatever be the input to this OR gate is going to give our y if we OR them. So the first input is QB complement, you can clearly see. So QB complement, and the second input to this OR gate is this one, that is my QA. You can see it is coming in this way and going as the second input to this gate. So QA. So y is my QB complement or QA. You can see A here. No, there is no A in this expression. The y is independent of A, that is our input. So it is clearly a Moore model or the Moore state machine. So this is how you have to check whether it is a Moore state machine or it is a Mealy state machine. And if you want to make the state diagram, then definitely there will be some changes in the state diagram that we will see now. If you have a normal, or you can say that the original state diagram having 4 states, let me draw these 4 states, and we will see what changes we have to make it the Moore state diagram. And in these 4 states, let's say this is our 0 0 0 1 1 0 and 1 1. Okay, and depending upon the inputs, the output is being generated, and also the state will change from one to another. Let me complete it randomly. 0 0, this 0 is my input, this 0 is my output. Then I am going from 0 to 1 1. If the input is 1, and then output will be 0. I am on 1 and I will be on 1 if input is 1, and then output will be 0. 1 1 to 1 0 for the input 0. Same state for the input 1. 1 0 to 0 1 for the input 0, and 0 1 to 0 0 for 1. And the last thing is this. Now this is original state diagram, and I want a Moore state diagram by using this state diagram. So what changes we have to do? We have to remove this output from here, and we have to put it under this state. So let's see how it looks. I will just make the bigger circles because I need to put the output inside this circle. Let's make it a little bit more bigger, and then I will write the state 0 0 0 1 1 0 1 1, and then the change is here. I have to make the output appearing inside this state. Okay, so 0 is my output, you can see 0 is the output, and 1 0 0, and the rest thing will be same. The inputs 0 and then 1 1, and it is my 0, then 1 0 0, and finally 1. This is my input, this 0 here is my output. So this is simply Moore state diagram, and you have learned what changes you have to make to convert it to a Moore state diagram, a modified state diagram for a Moore circuit, you can say, from the original state diagram. So this is all that you need to know about the Moore state machines, and I hope you got it. If you have any problem, you can ask it in the comment section. I hope it is clear to you, because it's not that much tough thing to understand. It's very easy. Only thing you have to remember is the output. The output is the function of present state only, and where the present state is been stored. It is stored in the flip-flop, our memory block. Okay, so it's very simple, nothing to worry about, and we will see the Mealy state machines in the next presentation.